dihedral angle of a least stable conformation of ethane. Okay, so just recall that ethane has means many conformations. What do you mean by conformations of ethane? So there are CH3 and CH3 group. If you draw the CC bond, the hydrogens are arranged. So because like this, because their bond angle is 109 degrees and it is sp3 hybridized. The carbon atoms of both the ethane are sp3 hybridized, and these carbon atoms can be freely rotated. This carbon-carbon bond is a single covalent bond which can be freely rotated. So because of this rotation, there are different possible spatial arrangement of the hydrogens are possible. So these different spatial arrangement of the of the hydrogen atom in the ethane is termed as conformations. Conformation. Yes, many conformation you can write. You can write many conformation. In one of the conformations, it is found that the hydrogen and hydrogens are on the same line. So they are on the same line. Okay, they are in the same line. So that means these hydrogens are in the same line. These hydrogens are in the same line. Okay, yes. So this conformation is called as eclipsed conformation. Eclipsed conformation. It is unstable. What is the reason? Because of repulsion between the hydrogen atoms. The hydrogen atoms get repelled. Hence, it tries to push the hydrogen atoms as away as possible. That gives rise to the rotation of the carbon-carbon single bond. Okay, so there's another gas. So here in this case, you can define a one angle called as dihedral angle. What is the dihedral angle? It is the angle between these hydrogen-carbon and carbon-hydrogen bond. So this plane, you can take this plane here, the CH bond and CH bond, if they are aligned in same direction, so the dihedral bond angle is 0 degrees. Okay, dihedral bond angle is 0 degrees. This conformation is considered as the least stable because of large repulsion between hydrogen and hydrogen, and this conformation is also called as eclipsed conformation. What is the other conformation? The other conformation is that when carbon and carbon are bond and hydrogen, the hydrogens are aligned such that they are not in the same line. They are not in the same line. Okay, yes, they are not in the same line. Yes, they are not in the same line. If you take the dihedral angle for this, dihedral angle, how to find out dihedral angle? We can just say that, so this particular green colored hydrogen, CH and CH, they form 60 degrees. Actually, the full angle is 120. From here to it is 120, but the dihedral angle is found to be 60 degrees. Okay, 60 degrees. So this type of conformation where hydrogens are not aligned in the same line, but actually they are aligned in the space between them. So these hydrogen, the hydrogen which is closer to us is in between the hydrogens of the other one. So that gives rise to a bond angle, dihedral bond angle of 60 degrees. This is the most stable okay, conformation, and it is called as a staggered conformation. Staggered conformation. Yes, staggered conformation. Bond angle is 60 degree, and this is the stable. Okay, this is the stable. That means most stable conformation. And what about that 0 degree eclipsed? This is the unstable or least stable conformation. Least stable conformation. Least stable conformation. Which one? Eclipsed form, for which the dihedral angle is 0 degrees. Okay, and this type of conformation of writing these bond lines is called as Seahars, okay, or Sahars, okay, Sahars conformation, Sahars conformation. This is applicable only for alkanes. Okay, alkanes, ethane, not ethene. Remember that. For ethene, we use the geometrical isomerism, but here these are considered as isomers, but they can be, okay, reversible. They can interchange. They can interchange. At high temperature, maybe eclipsed form is possible, but at low temperature, the staggered form is the most stable that is possible. Okay, in between these two conformation, if the arrangement of hydrogens are arranged such that the dihedral angle is anywhere between 0 and 60 degrees, they are called as Gaussian forms. Gaussian forms. Okay, Gaussian form. Gaussian forms. Okay, yes. Yes, this is the Seahars projection formulae to explain the conformation. You can recall that, okay, there is another way to represent the conformation of ethane. Ethane or even butane also, okay, butane also. Anyhow, let me write first for a conformation of ethane. Yes, that is called as a Newman's projection formulae. Newman's projection. Newman's projection formulae. So here, okay, first you know that it is CH3-CH3 is ethane. First you should write a one circle. Okay, after writing the circle, then after writing the circle, okay, right, 1 minute. So write a one circle, and then, okay, write the hydrogen atoms which are away from us with these type of lines, and the hydrogens which are closer to us, okay, like these type of lines, okay, like these type of lines. It is closer to it. Yes, here this angle is called as dihedral angle. The angle between hydrogen, carbon, hydrogen, dihedral angle. Here it is 0 degree. If it is 0 degree, it is called as eclipsed form. Okay, it's the eclipsed form. This is a 0 degree dihedral angle. It is eclipsed form. Okay, this is least stable because the hydrogens are repelled. It is the least stable. Okay, yes. And what is the most stable conformation? Write a circle and write the hydrogens which is away from us. Okay, like this. Then the hydrogens which are hydrogens of CH3 which are closer to us can be written like this. Okay, yes. This is this type of conformation is called as okay. So staggered form. What is the dihedral angle for staggered form? Okay, this is just 60 degree. Because of its symmetric arrangement, it is 60 degree. And this is 120. So this is 120 degree. Okay, half of it is the 60 degree. So dihedral angle is 60 degree. That gives the most stable conformation of ethane. most stable conformation of ethane. This is preferred at low temperature. Yes, this is about Newman's projection formula to guess the stable conformation and yes, to find the dihedral angle. Same thing can be written for butane. So what's butane? Butane is CH3, CH2 and CH2, CH3. Let us take this carbon-carbon bond, carbon-carbon bond, and the carbon-carbon bond, and arrange the methyl groups such that if they are in same line, that gives rise to an eclipsed form. That gives rise to a eclipsed form. Eclipsed form of butane. Eclipsed form of butane. And here we can write like this CH3 and CH3. If you write it, this is the eclipsed form of butane. And in this case, if you write CH3 and CH3, CH3 and CH3. So this is a staggered form, but actually, for a staggered form, this CH3 should be as away as possible, like this. In this case, dihedral angle for staggered form will be 180 degrees. 180 degrees. Yes, this is some theory about conformation of alkenes. So this comes under kind of isomerism called as stereoisomerism. Stereoisomerism. Yes, what is the stereoisomerism? So the compounds having the same functional group, but the spatial arrangement of the various groups are different. The compounds having the same molecular formula, same structural formula, same functional group, but spatial arrangement of the groups in space is the main difference between these isomers. Anyhow, so now comfortably you can answer the question as the least stable means where there is a most repulsion is 0 degrees, which gives rise to an eclipsed form. In ethane there is no 180, 120. I think you can just tell the most stable form, most stable conformation. Yes. Let's go to the next question. Noble gases are named because of their inertness towards reactivity. They are not very reactive because when you write the electronic configuration, the outer shell is completely filled. 2 electrons in helium, 8 electrons in the other noble gases. This electronic configuration of duplet and octet structure is considered as a very stable electronic configuration. Once the atom attains this configuration, it is very difficult to remove the electron or add the electrons. Large energy is required. That much energy is not available in most common chemical reactions. Yes. So before answering, you know that all the 4 options you have to read and select the correct option and prove that other 3 options are wrong. Then tick the or circle the correct options. That is the safest way. Noble gases are sparingly soluble in water. It's nothing to do with the chemical reactivity. Noble gases have a very high melting and boiling points. That is wrong because they are all gases. They have a low melting and boiling points. Noble gases have a weak dispersion forces. So this dispersion forces affects the melting point, boiling point and their solubility. Hence it's nothing to do with the chemical reactivity. Noble gases have a large positive values of electron gain enthalpy. So if you want to add an electron, large amount of energy is released. Yes, okay. Hence they don't form neither negative ions nor positive ions. So they don't exchange the electrons, they don't share the electrons, they don't form ionic bond, they don't form covalent bond. Therefore, safely you can answer that this is the correct, okay, correct information. But identify the incorrect statement about them. Oh, that's very, very important. It is nothing to do with the chemical reactivity. About the noble gases, okay, about the noble gases, we have to find the incorrect statement. Noble gases are sparingly soluble in water. Yes, it is correct. Let's see. Once you understand the question properly, how our options changes. Okay, this is the correct information. There is nothing wrong in it. Noble gases have a very high melting and boiling points. That's wrong. Okay, that is the incorrect statement. So that's the incorrect statement. Okay, that's the incorrect statement. Okay, we assume that they're asking the questions on reactivity. No, they're not asking. They just gave one important information to mislead us about to think about the reactivity. There are some 4 statements on the noble gases. You have to find the incorrect statement. Yes, noble gases have a weak dispersion forces. That is correct. So that is correct. There's no doubt about it. Okay, noble gases have a large positive. That is also correct. Therefore, what is the correct option issue? Correct option means incorrect statement. Noble gases have a very high melting and boiling point. This is our incorrect statement. Yes, this is how sometimes the information mislead the students. Okay, yes, let's go ahead. Question 53. The major product of the following reaction. So, following reaction. Yes, here you have an alkene. And you are having hydrogen bromide. And this chemical is called as dibenzoyl peroxide. It is dibenzoyl peroxide. Yes. As soon as you just know about HBr and peroxide presence, you must remember that it undergo anti-Markovnikov addition. Both should be present. It is just an addition reaction of an alkene. Okay, and recall the reactions of alkenes. Alkenes generally undergo addition reactions. Alkenes undergo generally addition reactions. But yes, whenever the alkene is unsymmetrical, what do you mean by unsymmetrical alkene? Okay, divide the molecule at carbon-carbon double bond, you won't get equal parts. That means carbon having double bond has sometimes more hydrogen. The carbon having the double bond should have a lesser hydrogen. Okay, yeah, lesser hydrogen. This type of an alkene is called as unsymmetrical alkene. When it undergo addition reactions, you'll get 2 set of products. One is major, another one is minor. Okay, the Markovnikov's rule help us to identify the major product. Yes, just recall the Markovnikov's rule. I'm just teaching as more theory as possible while solving these questions. Okay, hence maybe you know the answer. Okay, in such cases, if you know the concepts, you can just skip slightly. Okay, right. Otherwise, you can just listen. It will be a very good revision or reason for recollecting the information which you have already learned. Okay. Yes, Markovnikov's addition says that whenever any molecule adds across the carbon-carbon double bond, hydrogen always goes to the carbon having more hydrogen. Electronegative part attaches to the carbon having lesser hydrogen. Or reverse in NCERT, they are given in reverse order, no problem. You can remember in any way. Okay, so yes, this is the Markovnikov's addition. But remember that there is another addition. It is called as anti-Markovnikov's addition. It is also called as peroxide effect or Karash. Okay, Karash effect. Whenever HBr and hydrogen peroxides, okay, both are present. Whenever hydrogen bromide and hydrogen bromide and hydrogen peroxide both are present, the reaction, yes. So this undergo anti-Markovnikov's addition. What is anti-Markovnikov's addition? Anti-Markovnikov's addition. In presence of HBr and peroxide, hydrogen adds to a carbon having a lesser hydrogen, and electronegative part adds to the electronegative part adds to the carbon containing more hydrogen. Okay, have I told you correctly? Yes. So in HBr and peroxide both are present, anti-Markovnikov's addition take place. Okay. In anti-Markovnikov's addition, hydrogen attaches to a carbon containing lesser hydrogen. What is the reason? I think for reason you have to know about the mechanism of addition reaction. Then only you'll just learn about it. Okay. Yes. The first group which goes is, I think, free radical, hydrogen free radical, that gives rise to a hydrogen free radical. Yeah, so, okay, right. So that hydrogen free radical, whatever it is. Okay. So just you have to go through the mechanism to find out what is the reason for this. Okay. Yes. Now let's find the answer for this question. Okay. The bromine should be in the first carbon atom. The bromine must be in first carbon atom, not the second carbon atom. And third, this is not possible at all. Here, a substitution reaction not possible. This is just an option for misleading the benzoyl. Benzoyl peroxide. It doesn't have any role. Maybe in one of the steps, the benzylation may occur, but that's not the end product. It acts just like a catalyst. Therefore, this is the product. Naming 1, 2, 3 and 4. Longest chain you have to name, number the carbon atom such that the functional should get a minimum number. Hence it is 1 bromo 3 methyl butane. Okay, yes. Okay, students, let's go to the next question. Yes. A particular station of All India Radio, New Delhi, broadcast on a frequency of 1368 kilohertz. The wavelength of the electromagnetic radiations emitted by the transmitter is. It's a simple question based on the velocity of light. We know that velocity of light or any electromagnetic radiations, not only light, even ultraviolet light, visible light, X-rays, gamma rays, they all travel with the same velocity. They all travel with the same velocity of 3 into 10 to the power of 8. That also they have given. But how is the velocity of light is related to the frequency and wavelength? If nu is considered as the frequency, lambda is the wavelength, that's how they are corrected. They are asking for the wavelength. So divide C by nu. C by nu. Yeah, C is 3 into 10 to the power of 8 meter per second, and quickly divide it by 1.1368 into kilo. Remember, kilo is not the unit. Kilo is the just prefix for thousand. Prefix for thousand. That thousand number we have to take it. The thousand number we have to take it. Okay. So then only, if you without thousand, if you take that for calculations, we go wrong. Therefore, the wavelength is equal to just 3 into 10 to the power of 8. And now write this as in terms of thousand. 1.36 into 10 to the power of 3 and another 10 to the power of 3. Okay, 10 to the power of 3, 10 to the power of 3. So that becomes 10 to the power of 8 divided by 10 to the power of 6. I think you have understood what I am doing. 1368, I can write it as 1.368 into 10 to the power of 3. Okay, I am decreasing the value, so I increase the power. So that comes down to just 3 divided by 1.368 into 10 to the power of 8 minus 6, that is just 10 to the power of 2, that is 100. Okay, now you have to do a little bit of approximation. Approximation, you have to do it. Okay, approximation. 3 less than 3 is 1.5. If it is 1.5, you will get 2 times, because 2 times. If it is slightly less than 1.5, you will get 2 more time. Maybe let's take it as 2.19 multiplied by this 10 to the power of 2, that is 100. 219 meters. Okay, no need to go for actual division. Actual division we don't want. Approximation will save you a lot of time. Okay, 3 divided by 1.368, right? I assume that 3 divided by 1.5, close value. So 1.5 get 2 times, but because it is actually slightly less than that, you will get more than that. 2.19, but 10 to the power of 2 is nothing but 100 if you multiply 219. Okay, 219 points. Okay, whatever it is. So 219. Oh, look at this. Look at this. We can't approximate so close values. How can we know that it is 0.3 or 0.2? You have to divide. This type of questions should not be given. It's waste our time. It is ruled out. This is ruled out. But 219.3, 219.2, they are so close. Then actual division. Are they testing our ability to divide that within so short time? So hence, such type of question should not be given. Okay, anyhow. So let me take the calculator and divide. 3 divided by 1.368, 2.192, but if it is round off 193, it is coming. After rounding off, oh, that's okay, it consumes lot of time. So you have to round off. You may get okay, 2 point, that is 219.2, but it should not stop dividing to continue to divide to find out the next term, whether it is greater than 5, less than 5. Okay, anyhow, it's a bad question. We can't help. It is testing our not only the chemistry knowledge, but division. Okay, right. Okay, students, let's go to question 55. The incorrect statement among the following. They are helping us to giving incorrect statement in bold letter. Okay, actinoid concentration is greater for an element to an element than the lanthanoid contraction. Yes, first read all the 4 options. Most of the trivalent lanthanoid ions are colorless in solid state. Lanthanoids are good conductors of heat and electricity. Actinoids are highly reactive metals, especially when finely divided. Okay, let's go to the information which we know it correctly. What is that? Lanthanoids are good conductors of heat and electricity because they comes in metals. They comes in D block elements. They are also metals. Metals means they should have the metallic property. They are not coming under non-metals. Okay, that is right, but that is not our option. Incorrect option we have to find out. Anyhow, actinoids are highly reactive metals, especially when they are divided. You should know that they show the variable oxidation state, not only +3, +4, +5, okay, and all those okay, very oxidation state shows. And here you have the outermost orbital or 5 orbitals. They are bigger orbital. They are slightly away from nucleus. The many electrons may be removed, added, etc. Hence they may undergo. They are more reactive. That we know it. Okay, more reactive, but when compared to actinoids, that's also correct. There's nothing wrong in it. Actinoid contraction is greater for an element to element. This is also correct. You know that lanthanoid contraction is very smooth. If you go from one lanthanoid to another a small change in the radius occurs. A smooth decrease in the radius of the lanthanoids and lanthanoid ions. That is also correct. Most of the trivalent lanthanoids are colorless. This is wrong. This is wrong. Why do you think it is wrong? Okay, the theory says that, let me write the lanthanoid electronic configuration. Okay, it is 6s2, outermost electron 6s2, 3d1, and then comes the 4f1, 4f2, 4f3, 4, like that it will go. Okay, and if you remove these three electrons, it shows the +3 oxidation state. Okay, all lanthanoids shows the +3 oxidation state. Once they show +3 oxidation state, there are there are partially filled electrons in f orbitals are present. Okay, just remember, many d block metal ions are colored. The reason is that they may undergo transition from one d orbital to another d orbital by absorbing the visible light. Same thing happens whenever f orbitals may also split. There are 7, no problem. They also may split under the ligands or water, and there is a transition of electrons from one 4f orbital to another 4f orbital possible here. Hence, we can say that, surely we can say that, because many d block metal ions are also colored, even in case of lanthanoids and actinoids, in most stable oxidation state they are also colored. So, but they are saying that it is a colorless. They are a colorless. Therefore, our incorrect answer is this. Yes, our incorrect. Most of the trivalent lanthanoids are colorless. That is wrong. They are colored. Right. Okay, students, let's go to the next question. Right option for the correct option, should say, not right answer or left option. Okay, anyhow, the correct option for the number of tetrahedral and octahedral voids in a hexagonal primitive, the cell. Okay, anyhow, we are learning, I think you are all preparing for the Neet examination in 2024 onwards. This lesson has been removed from the syllabus. This lesson is removed. This comes from the solid state. The solid state. From the lesson solid state they have removed. Hence, no need to bother about this. What is meant by the tetrahedral void and octahedral voids. Okay, maybe your teacher also must have not taught the lesson. Hence, even if I explain also, I think you may not follow it. So, better you leave this question, okay, out of syllabus. Okay. Yes. Identify the compound that will react with the Hinsberg reagent to give a solid which dissolves in sodium hydroxide. Okay, students, let's recall what is the Hinsberg reagent. What is Hinsberg reagent and which lesson Hinsberg reagent comes, and how do you use Hinsberg reagent to classify? Yes. First of all, the Hinsberg reagent comes in the amines lesson. That you have to recall. In amines, there are few categories of amines. Primary amine and two alkyl groups, if it is present, it is called a secondary amine, and tertiary amine do not have a hydrogen attaches to the nitrogen. Yes. Next, recall what is Hinsberg reagent. It is a big reagent. Okay. Benzene sulfonyl chloride. Yes. Benzene sulfonyl chloride. Minus, and this is a minus group. Anyhow, this is a minus group, and one of the oxygen atom get a positive group. Yes. So, positive group. This benzene sulfonyl chloride always attacks the lone pair of electrons in the nitrogen. And When it attaches here, you will get, I'll write a big group as some kind of phi. Okay, and no need to write everything. Okay, yes, big group. And this is a two hydrogens. You get a positive charge. That positive charge will get neutralized by when throwing out the hydrogen. And now you will get a, okay, now you will get a compound, okay, in which the sulfonyl group is attached. Sulfonyl group is attached. The sulfonyl group speciality is that it is highly electron withdrawing group. Highly electron withdrawing group. These highly electron withdrawing groups makes this okay, acidic. Make it acidic. Okay, it can give the proton. It can give the proton. Hence, when benzene sulfonyl chloride reacts with the amines, you will get a substitution product. It has one hydrogen attaches to nitrogen, which is next to the highly electron withdrawing sulfonyl group, and make it acidic. Hence, it dissolves in sodium hydroxide. It dissolves in sodium hydroxide. If you take a secondary, okay, amine, it reacts with benzene sulfonyl chloride, but that doesn't contain the acidic proton. Hence, it is not insoluble. It is insoluble. Okay, actually, I should teach neatly, but because already have learned, okay, my other videos will be there, in which I'll teach the theory informations neatly. Okay, so that lessons you can follow it. Okay, for that I'll request you to subscribe to my channel and share to your friends, so that you are helping me. By doing so, you will get more and more beautiful okay, so videos in which all the information is clearly explained. You can save lot of your time by just recalling the information which I've already taught, okay, with my help. Okay, yes, thanks for your supports. Okay, let's go ahead. Okay, benzene sulfonyl chloride, okay, reacts with okay, primary amine and secondary amine. What about tertiary amine? Tertiary amine, it's not possible, because it may attach to the, benzene sulfonyl chloride may attach to the nitrogen, but it cannot stabilize. So it cannot stabilize. It cannot stabilize because you get a positive charge, which you can't remove the alkyl group. Very strong bond, you can't remove the alkyl group. Hence, there's no product form. There's no product form. Therefore, okay, Hinsberg test is used. Okay, Hinsberg test is used to identify what? So, to primary, secondary, and tertiary amine, the way with which they react with benzene sulfonyl chloride. Okay, the way with which they react with benzene sulfonyl chloride. Primary amines, yes, they react, and you will have an acidic proton. Okay, that acidic proton helps it to dissolve it in okay, sodium hydroxide. Hence, in this question, you have to find out which is the primary amine. Yes, first option is ruled out, nitro group don't react. Second option is ruled out, it is secondary amine. It may react with benzene, Hinsberg reagent, but it doesn't dissolve in alkali. And third case, yes, it is primary amine. It suits all our requirement, and you have to prove that. Fourth one is wrong option. It's a tertiary amine. It doesn't react with the Hinsberg reagent benzene sulfonyl chloride. Therefore, what is our correct option? Our correct option is option 3. Okay. Yes. Okay, students, let's go to the next question. Which of the following reaction is the metal displacement reaction? Oh, this question is about the classification of the chemical reactions. Okay, just recall that. The first type of chemical reaction is combination reaction. When two elements combines to form a compound, it's a combination reaction. It's also called a synthesis. Decomposition reaction. One single reactant gives rise to two or more products on heating is called as the decomposition reaction. And then comes the simple displacement. In simple displacement, metal displacements and hydrogen gas displacement, there are two categories. And fourth category is the double displacement reaction. Okay, yes. Now let's go to the, okay, yes, right option we have to select metal displacement. You know the displacement reaction, but if you read only displacement reaction and go to the answer, you may pick this option. Remember, word by word you have to read in the question. Word by word, every word plays an important role. In a hurry, if you read just, oh, which is a displacement reaction, oh, I know displacement reaction, iron displaces hydrogen, and if you go, then, okay, you may lose the precious 4 marks for it. So, hence, read the adjective before the word, metal displacement reaction. Okay, so let's go option by option. This is ruled out because it's a decomposition reaction. Second one, aluminum displaces chromium from chromium oxide, and this is actually the metal displacement reaction. Whereas the second one, the third one, iron displaces hydrogen, so which is a non-metal. You can write it as a non-metal displacement reaction. You might have not learned there as a metal displacement, non-metal displacement. By using the simple information, some common information, you can say that option 2 is correct. Lead nitrate, this is the decomposition reaction, thermal decomposition reactions. So first one and fourth one, thermal decomposition reaction. Second and third are displacement reactions, but the second one is the metal displacement reaction, and the third one is the non-metal displacement reaction where hydrogen gas is released. Hence, okay, easily you can go for the option 2. Right. Next, question 59. Given below are two statements. Statement number 1, aspirin, paracetamol, okay, belong to the class of narcotic analgesics. Morphine and heroin are non-narcotic analgesics. Oh my God. Okay. I have to check whether even this lesson is also removed from the syllabus or not. Okay. This earlier, this information was come under the a topic called as yes, some chemotherapy and some useful chemicals in everyday life. Okay, in that these concepts used to come, but because in theory in NCRT they have reduced 40% of the syllabus, in that this lesson is completely removed. This lesson is completely removed. Hence, we can consider this as an out of syllabus question. An out of syllabus question. Okay. The students who are writing after 2024, no need to bother about this information. Okay. Right. Yes, question 60 is very tricky question. Okay. Yes. So, what is the IUPAC name of the organic compound formed by the chemical reaction? Acetone. This is a Grignard reagent. Okay. Acetone and Grignard reagent. And this on dry ether and hydrolysis. There's nothing to bother about this. Okay. Yeah. So here you should know the theory behind it. This comes in the preparation of alcohols. This topic comes in the preparation of alcohols. Let me teach the so theory. Let me teach the theory. Okay, theory. Okay, that theory says that take formaldehyde, methanol, formaldehyde, make it react with Grignard reagent. Any Grignard reagent is okay. MgBr. Ethyl group attaches to the carbon. This magnesium attaches to there, and that gives rise to an intermediate. Okay, so you will get an intermediate OMgPr. This on hydrolysis, you will get an alcohol. What is the alcohol? You will get C2H5, H, H, H and OH. Yes. This is the primary alcohol. If I take formaldehyde, its IUPAC name is methanol. I'll get a primary alcohol. This is point number 1. Point number 2. So instead of methanol, take any other aldehyde. Let's take ethanol. Okay. Let's take ethanol. Okay. I'll change here only. Please okay. Let me remove this. So instead of this, let me take a CH3CHO. It is ethanol. Acetaldehyde. If I take acetaldehyde or any other aldehyde other than the first aldehyde, formaldehyde, you will get this reagent. Same thing. So instead of this CH3, C2H5O, and you will get a compound having a CH3, C2H5 attached to same carbon atom. And this one is a secondary alcohol. The product formed is a secondary alcohol. Hence, if I make a formaldehyde or methanol with the Grignard reagents, at the end after hydrolysis I'll get primary alcohols. With ethanol I'll get secondary alcohol. What about acetone? Acetone is a ketone. Yes, for acetone is a ketone. Acetone, you have a 2 CH3 groups in the middle, there's a CO group. And here what happens, C2H5 groups when it's attached, so you will get this group having 3 alkyl group. This on hydrolysis, you will get a tertiary alcohol. So you will get a tertiary alcohol. This is the theory. So methanol gives the primary alcohol with the Grignard reagent. Ethanol gives the secondary alcohol with the Grignard reagents. Ethanol or propanol or whatever the aldehyde, acetone or any ketone gives the tertiary alcohol. This is the theory. Now because your starting compound is acetone, already 2 CH3 groups are there. Already you have a 2 CH3 groups attaches to CO group. If one more ethyl group from the Grignard reagent comes, definitely you will get a tertiary alcohol. Hence you have to look out for the tertiary alcohol in the tertiary alcohol. You have to look out for the tertiary alcohol in the product. For that you should be good in writing the IUPAC structures. Okay, let me write a 2-methyl propane 1-nol. Yes. Before that you should remember what is the product formed. You will get a CH3, CCH3. These groups are already present, and this is a C2H5 group, CH3CH2 and then OH. This is the compound we should get. Okay, now write the structure. I will teach you how to write the IUPAC structure, means the structure of the organic compound from IUPAC name. Propane, 3 carbon atoms. A second position alcohol, methyl group. Okay, then when you compare that, this is not the option which we are learning. Pentane 2-ol, right? 5 carbon atoms. Right, 5 carbon atoms on OH group. This is not the product which we are expecting. Pentane 3-ol. Okay, 1, 2, 3, 4, 5. This is also not the compound which we are expecting. Therefore, it must be the fourth compound. I need a butane. First write 4 carbon atoms. Okay, yes. And second position OH, yes. And second position OH. And second position methyl group, yes. So correct. two methyl group and one methyl group is attached to a carbon, okay, tertiary alcohol. Therefore, you can aram se go for this statement. Okay, so like that. Organic chemistry questions easily you can answer it confidently, provided lot of effort has been put to learn the theory and write and practice many equations, and by looking at the reagents you should guess what type of reaction it is in NCRT, where it comes, what they have taught, what answer, what product, that we have to. Okay, fine. Okay, you should not guess the product by looking at the reactants. Okay, some strange products you may get. Okay, okay, student.